Hey, it's Bob again, and today I'm going to start actually talking about the slip gun, which is used to pump liquid clay into molds. And really, it's not the gun today that I'm talking about, it's the peristaltic pump. I want to build my own because I'm on a budget. I'm retired, don't have a lot of extra money. So the the intent is to see if I can build something that actually works. And I'm going to be 3D printing most of the parts. So as a quick reference, here is my first attempt at a 3D printed peristaltic pump. I've done a couple of brief tests with it, and they weren't eminently successful, but they're pointing me in the right direction, I think. So I think maybe the first thing I'll do is try and disassemble this without wasting too much time. So the plan here, as I designed it, is that it should be fairly easy to take apart. So I've got a clamp here, and one of the things I noticed today when I was putting it back together is I've actually, I don't think this is going to show in this. Yeah, you can't see it. There's a fracture here. So clearly this is already, I found a failure point, and I've probably run this for, I don't know, maybe 10, 15 minutes total as I've tried pumping different substances. But the intent was by using a clamshell that I could easily get to the pump itself. So let me pull this other part apart because it's extraneous now. Well, it's not extraneous. This is, in fact, the race. This is what pumps these lobes pump against. So what they do is they compress the tube while it's, they're rotating, and it grabs a little bit of slip. It grabs some slip and forces it around and pumps it back out. So what have we got here? So I'll have to remember which side the camera is on today. So I'll take a couple of these pieces out so that we can actually get all the way down to the pump, to the part that matters. And, if I've done this, the approach I'm using, I think, is fundamentally sound. I just think I'm going to need to beef things up. It's, when I pumped water with it, it was actually fairly successful. It was I was pumping it around 6 liters per minute. And although I had some problems with my very first attempt pumping slip, numerous problems, I did actually succeed in achieving about a 4 liter per minute pump rate. But it was a pretty rough trip. So let's see if I can pull this out of here. It's stronger than I am. Wouldn't be surprised about. There we go. So this is the rest of the pump, and it's just silicone tubing. And one of the problems I realized is that the lumens, the size of the hole for this happens to be 1/2-inch PVC. That's one of the problems. I needed, I think, either 3/4 or maybe even 1 inch to be feeding the pump. I think that was one of the problems I was having. One of the other problems I identified was that this tubing actually wanted to fold and travel around inside, and that led to other issues. Because again, it doesn't show too well here, I'm afraid, but these got pretty well beat up. So I've got 2 different styles of lobes here. I started out using 3 of these bearing rollers, and I thought, well, that's awfully heavy, and they're not cheap. So I 3D printed a spacer with a couple of spacers, and that's really the essence of the pump. This is just an 8mm shaft, more of the bearings, and a couple of split collar clamps. And the power is transferred through these flanges in here. That one of the challenges I found was Everything kind of wants maybe a D shaft. That's a shaft with a flat surface on it so that you can clamp everything down well effectively. They pretty much are impossible to find, at least in the size I started this design with, which was 8mm. And the reason I went with the 8mm was the stepper motor that I bought has an 8mm D shaft on it. And that was a fair investment. So that's where things stand at the moment. This is definitely a work in progress. I will be incorporating some short clips into this. I'll see if I can figure out how to edit it appropriately. Yeah. So my first clip is here, and this is pumping water. And as I mentioned, it's ultimately about 6 liters per minute.
It's alive! It's alive!
Attempting to pump slip, it actually does pump, and it does pump 4 liters over a minute, but it's straining. And actually, when I was done, I could smell burning plastic, which is probably not really great for the longevity of this pump. But all things in good time. So talk to you again soon. Okay. Well, it's running in the right direction. And kind of that's where things stand at the moment. The print times are such that to print this at the level of strength that I'm looking for in detail, that's a 24-hour print. And so, you know, minor changes are not minor if they affect the major parts of the device. But that's kind of it for the moment. It's been an interesting process learning how to do this, and I think I will eventually have a 3D printed peristaltic pump that will pump slip from a tank that I'm going to use. I've bought a 20-gallon laundry tub, and that'll hold my clay, and I want to pump out of that and fill my molds. So that's kind of it for now. Let me see if I can figure out how to edit this in a way that makes some kind of sense. Until next time, talk to you soon. Have a great week.